Simon.
Do you hear me? Yeah. Just a bit higher. So this talk is really 3 talks in one. I mean, the title is Advanced Aspects of the Django Ecosystem, because really one of my favorite things about working with Django is the enormous array of stuff that's out there that isn't just the core framework. And so for this talk, I've picked 3 projects which I find invaluable in the projects that I do myself. 3 things which I really think of as, they're kind of secret weapons. I have a bit of an unhealthy obsession with the idea of finding tools that really give you a major competitive advantage without actually having to invest too much effort. So I like finding out about things where, with a very sort of small learning curve, it gives you the ability to build stuff that you just couldn't have built previously in hardly any time at all. And so the 3 tools I'm highlighting today are Haystack, Celery, and Fabric, all of which have a very low learning curve and give you the ability to quickly deploy quite complex pieces of functionality in any Django-powered web app. Now, to give you some context, all 3 of these are things that I've used on my current project, which is a site called lanyard.com. Lanyard is a social conference directory. It's a site that helps you find out about conferences to attend, build up a profile of the talks that you've given at events, and catch up with slides, video, and notes that are collected after the conferences. So it has pages about conferences, but more importantly, it has it's all integrated with Twitter. So when you sign into the site using Twitter, we look at who you follow and show you events that we think you'll like based on the people you are following. So here I'm seeing all of the events which the people I follow on Twitter are speaking at or attending. And we also encourage people to build up these detailed speaker profiles of everything they're going to in the future, things they've spoken at in the past, books they've written, all of that kind of stuff. So it's a relatively complicated web app. At the moment, the team is just 2 people. It's myself and my wife, who does all of the front-end development. So to build something like this, I was really looking for stuff that let me roll out complex chunks of functionality with 1 developer hacking on things as fast as I could. So the first component I want to highlight is something called Haystack. Now, Haystack calls itself Modular Search for Django. And it's a package which makes it really easy to add quite powerful full-text search to an existing Django project by hooking into the existing set of models that you've already created. Haystack's very close to my heart because a couple of years ago, the Science Museum in London ran an API competition. They put out an API with an enormous XML dump of all of these things from one of their collections. Said, hey, hackers of the world, have at it, see what you can build. And my wife and I decided we'd have a go at this one afternoon. So we grabbed our XML file, fired it into Django, used Haystack to build a little search interface over the top. And despite only putting about 6 hours of work in, we won the competition and walked away with £1,000. Fantastic. And which we probably should have donated straight back to the Haystack project, because that was basically all that we'd done. So what Haystack lets you do is build interfaces somewhat like this. So in this case, I'm searching for the string moon, and I've got various different types of objects in this system. In this case, because it was a museum collection, we have people, museum items, and celestial bodies, because the exhibition was to do with astronomy. And Haystack is very model-oriented, so if you're not using Django's ORM, it's mostly not that much use. But if you are, it's very quick to spin up a search interface like this, or something indeed a lot more complicated. And the steps for doing so are incredibly simple. It's very similar in a way to Django's admin interface. You drop a file called servers.json into one of your Django apps. You define a couple of classes for each of the models that you want to include in your index, look at their default views, run a command, and you've got a full interactive search interface up and running. This is, for the museums project, this is what the code looked like. So I've got a class called, you import some Haystack boilerplate, and then pull in the Django models. In this case, we had a museum object, a person, and a celestial body, all standard Django ORM stuff. Then for each one you want to include in the search index, you define a class which extends indexes.searchindex, and then in that you can define the different fields of the model which you want to be indexed. In this particular case, the only field we have is a text field, which, because it has document equals true, that tells Haystack this is the field that's going to be searched against. This is the field that, when somebody searches the moon, should have matches found within. And you define a query set, which returns the objects which should be included in the search index. That's kind of useful if you're doing something like a blog system where some entries haven't been published yet. You can make sure that the index only covers published entries where published equals true. And then, just like the Django admin, you register your museum object with the Haystack site object, give it the index, and you're basically done. Haystack ships with a bunch of view code built in, so you add one line to your URL configuration saying that the search path should map onto Haystack. And then you write a template, which again is very straightforward. This template is showing a pattern which I've used in a lot of my Haystack-related projects, where for each result, you look at the type of the result and then spit out a different fragment of HTML. So back here we've got one where formatting results is less to bodies, another for people, and then the objects get a photograph and we'll read more link at the end. And that's done using Haystack's page.object list that passes through to your template for you. Is that legible, by the way? I had to switch from a lighter template to a dark one just 30 seconds before the talk started. So we loop through the results. If the result model name is museum object, we spit out that kind of that fragment of template. If it's person, we spit out that fragment. And the object that we get is a result object, which is something that Haystack has given back. But then anytime we access .object on that, so there's a bit there where I'm getting result.object.image in line, that's actually dealing with a proper database object. It's an ORM object that Django's returned. So Haystack deals with the problem of retrieving objects from the database that relate to the things that come up in the full-text search. So with just a couple of files, you've got a relatively decent, usable search interface across a whole bunch of different bits and pieces. So that's the really simple case. And then the fun part comes in scaling that up from one tiny little site for sort of collection of 100 items to something with hundreds of thousands of different pieces of data in. Haystack, just like Django's ORM, Haystack supports multiple backends. So the first thing you do when you install this is you pick which of those backends you're going to use. There are really three that are worth looking at. There's Whoosh, Solr, and Zapier. Whoosh is a pure Python full-text index. It's a Python library which does actually a pretty good job of tokenizing and building up an index and all of the things that you might need. And so for small sites like the Science Museum site, because it was mainly static content, it didn't get updated very often, and that kind of thing works just fine. You can drop it in without having to configure any external servers, run the command to create the index, and you can start running a site off it. So I suggest looking at Whoosh if your site is something like a blog or something that doesn't really get much traffic. There's Zapier, there's another option, which is an embedded C library, which I haven't used myself, so I won't go into it. But really, the sort of default choice for Haystack when you're using it for something larger is the Apache Solr project. Solr, if you haven't seen it before, is another one of these secret weapons. It's something where if you're using it, you can build enormously complex and powerful functionality with very little effort over the top. It's a Java server which essentially runs on a machine. It speaks HTTP, and you interact with it through posting documents to it to add them to your search index, or running GET requests with query strings to run searches against the stuff that you've collected. So if you fire one of these things, you can essentially just start shoveling all sorts of different types of data into it, get it all in one place, and then run powerful sort of structured searches over the top. And so if you've got Solr, once you've got Solr set up, which is relatively straightforward for a Java web application thing that you have to run somewhere, there are RPMs for Debian packages and stuff, you can do all sorts of really powerful stuff. And for me, I think the killer feature of Solr is its support for what's called faceting. So this is an example of Language search engine, which has an awful lot more stuff in it than the museum one. And so you can see I've searched for Django and I found 459 objects from the site that relate to Django in some way. So we're seeing we've got a topic of Django which relates to different conferences. We've got a book about Django, practical Django projects. There's one of our users who has Django in their name. There's a set of slides from DjangoCon 2008, 2009. There's a whole bunch of different object types coming up here. And then down the right-hand side, you get these filters. And so this is saying, you search for Django. Now, if you restrict it to just objects that are sessions at a conference, then you'll get 207 of them. If you restrict it to just conferences, then we've got 60 conferences about Django. If you restrict it to just people, then you'll only get one result. And all of this processing, all of this sort of digging up of what types there are, what number of results you get when you filter by those. That's something that's all baked into Solr, which Haystack provides a relatively low-level API over which you can then use to build this kind of interface. So if I click on some of those, if I, for example, say I want sessions, and I want sessions where the topics include NoSQL, and that were presented somewhere in the United States, it knocks those 500 results down to just 3, which are two sessions given at DjangoCon US and a session given at Strata in February of this year. So it's a really good way of helping users overcome that sort of glut of information. They've got way too much stuff. You want to guide them through the process of narrowing it down to something that might be more relevant to what they need. Now, I won't show you the way the faceting code works, because that's kind of horrible. I need to clean it up and release it properly. But I'll just give you an idea of what Haystack looks like for this kind of more complex application. I'll show you the configuration that we use for our books. So this, again, is very similar to the museums thing. We've got a book index, which extends the Haystack search index. Again, we've got this text field that's searched through, but we also have two other fields that we define. There's speakers and there's topics. The reason we have those is so that you can run searches like show me books by this particular author. I'm using speakers because it maps to our conference model, but it's essentially authors in this case. Or show me books, search within all of the books where one of the topics is Django for this particular string. But it's incredibly simple to build these up. You define the two things. You create prepare methods for each one. So the prepare speakers method returns the user IDs of any authors attached to that object. Prepare topics is passed to the book from the database and returns a list of the topic IDs, both of which end up in that index. And having done that, you can then do these faceted searches. You can say, give me all of the books which relate to this topic, and which involve this author, and which match this search term. So you can build up some very powerful interfaces from just a few lines of configuration in here. There's one other thing which is going on here, which I think is quite powerful, and that's that in the text field, the field that actually gets indexed by the search engine, we have an argument use template equals true. And what that tells Haystack to do is use a standard Django template file to generate the text which will be used in the index to represent that item. So this is what our template looks like for the book text. The book is passed in as the keyword object. We're indexing against the object title and the object tagline, so that's the book title and the book sort of subheading. And then we're looping through all of the authors of that book, and for each one we're including their name and, in this case, their Twitter screen name as well. So if you were to search for someone's Twitter name and we knew that they'd written a book, we'd be able to return that in the results. And we loop through all of the topics attached to that book as well, and add those. So if the books have a topic of Django applied to it, searching for Django will return the book, even if that wasn't in the book's title. An interesting trick you can pull with this is, since this is essentially splattered straight into the full text index, it actually gives you a very rough and ready way of controlling your search engine relevancy. If you think the book's title should be more relevant than other aspects of the book, you can just put object.title in twice, and it actually works, at least for Solr, it works really well in boosting things up the hierarchy. So that's the way we're using Haystack for straight-up search, which is a relatively sort of what you'd expect to do with it. But another aspect of the site that we use for Haystack is something that you wouldn't necessarily expect, and that's our key feature, the thing where you sign into the site using Twitter, and we show you all of the events that your contacts are speaking at or attending. And this page here is actually generated by a call to Solr, using the low-level Haystack API. So essentially, we pull the list of people you follow on Twitter, which for most people is sort of 100 to 200. For a few outliers, it can be 1,000 or more. And we pull in that list of IDs, and then we do a search against our search index for things where, for conferences where the attendee matches this person or this person or this person or this person. I think Solr by default can do up to 1,048 Boolean terms, or 1,024, and you can double that in the configuration. So as a sort of quick and dirty way of getting this kind of use work, it actually works really well. When we launched the site 10 months ago, we had a big gnarly SQL query generating this page, which lasted all of half an hour under the onslaught of people checking the site out. So I can recommend this as a certainly a more scalable approach for solving that kind of problem if you're in a bit of a hurry. And the code for that, again, this is using Haystack's low-level API. Haystack gives you an object called a search query set, which is very similar to a Django query set. It has the same kind of chaining mechanism set up. So in this case, I get a search query set. I tell it I only want to search on conference models. Again, Haystack is aware of the ORM, so passing in the conference object is enough for it to know how to filter. Then we cobbled together a string of all of the contact IDs with or in the middle, so X or Y or Z. Run a narrow filter, which actually uses Willison syntax to narrow things down to just attendees, which match that string. And by the sort of fifth step, they now have a search query set, which once evaluated will run a search that gets you just the conferences that people that you follow are attending. So the big challenge with any search index is how you keep the thing fresh, how you push new content into it, and how you make sure that content that has been changed in the database is reflected in the search index. There's a general rule: most search software doesn't really like being updated. It's optimized for reads, but often they'll ask you to submit writes in big batches, or in there's some search software out there which actually requires you to rebuild the index from scratch and then swap it in whenever you want to make a change. Haystack has a whole bunch of solutions for that. There's, if you have a low traffic site, there's a real-time search index class you can use instead of the regular search index, which actually sets up Django event triggers so that whenever you change something in the database, it's automatically written back out to the search index. That works fine for low traffic stuff, but if you've got a lot of writes going through, that's going to be pretty inefficient, especially against something like Solr, which really prefers to do updates in batches of sort of 50 to 100 documents at a time. You can also use Haystack's update index management command, which you can configure to only index things that have been changed in the past few hours. So you can run it on cron job, say, once an hour, update everything that was modified in the last hour using an updated field from the database itself. But really, if you're going to do something large scale with it, you need to roll your own solution at the moment, which either using a message queue or some other mechanism for keeping track of what's changed. So the way we're doing it on Lanyard is ridiculous. It's probably the simplest thing that could possibly work, but we find it's been working very well for us. We just have a Boolean field in the database on every one of those objects that ends up in the search index. So in this case, if we had a blog article, there'd be a needs underscore indexing equals Boolean, which defaults to true, and then the indexer can look at the full text search engine can look at all of the items that need indexing, grab them at sort of 100 of them at a time, push them into the index, and then set that flag to false. So then, to actually update it, you just have, in your object save method, you set it to true before you save the object to the database. And I'll be posting these slides up later, so all of this code will be available. But at that point, you just need a management command or equivalent, which every now and then pulls in everything from the database that needs indexing, loops through it, pushing each one into the index update object method, and then writes back to the database, sending those flags back to no longer needs indexing because it's been updated. The advantage of this, especially if you're using something like Solr, is you can take advantage of Solr's replication. This was something we were quite concerned about when we realized that the most popular page on the site was this home page that shows you all of the events that your contacts are going to. And yet this was also one of the most complicated pages. It was doing quite an expensive search query every time somebody visited that page. So Solr, just like similar to MySQL, Solr makes it very easy to have a master server, which you send all of your writes to, and then a bunch of slave servers, which replicate from that master every sort of 20 to 30 seconds and maintain a full copy of your index. As long as you send the writes to the master and then balance the reads between the different slaves, you can pretty much scale horizontally when it comes to running queries. So in our case, I think we've got 4 slaves up and running now, so every time somebody hits that expensive homepage, we can load off to one of those 4 different servers, and we can add more servers as and when our traffic goes up. But we actually ran into a problem with this in that the current production version of Haystack doesn't have a very easy way of talking to different servers for different types of search operations. But this is where having something like Solr which speaks HTTP becomes really useful. What we realized is that we could take our existing load balancer, nginx, and set it and stick Solr behind it. So in this case, this is nginx configuration syntax. We've got nginx listening on port 8983, And if the location matches Solr/update, it passes it through to a Solr master, to a master server. And if it matches Solr/select, which is search queries, it passes it through to one of the slaves. And then we just add slaves into that piece of configuration there, and nginx will handle all of the load balancing between them. So that was one of those things which, it was sort of 2 o'clock in the morning, the site was going down, and I needed to get it talking to a bunch of slaves, and suddenly I realized that I didn't have to write any Python code at all, which was pretty cool. So I'll take a moment now to take for any questions about sort of, full-text search and Haystack and the way that we've been using that. There's one there.
I'm a total beginner at full-text searches, but how does the Haystack refer to Lucene?
So Solr is essentially Lucene. Lucene is a Java full-text search library. Solr basically takes that Java library and gives it an HTTP interface, and then Haystack lets you talk to it. So you can get all of the advantages of Lucene, which is like 15 years old now, and a very sort of robust and high-performance search engine without having to write any Java. Whoosh, which I mentioned earlier, is essentially a sort of mini Python version of Lucene. It's not nearly as sort of high performance or comprehensive, but it does mean that if you don't want to run a Java application server just to get search working, you can drop in some Python code that will do a reasonable job for a small data set.
Did you run into the problem having a too big index? And what is better, using several Solr instances or using the multi-core feature?
So, at the moment, our index is small enough that it's fine. I mean, we're running Amazon EC2 large instances, which have 7.5 gigabytes of RAM, and it'll be quite a while before we completely fill that up, especially since most of the objects we're indexing are quite small. It's the title of a book and the authors, but it's not like a sort of 2,000 word long essay. The way Solr deals with large indexes is quite interesting. You can run multiple Solr masters, so you can split your index across multiple different Solr instances, and then you can run a query against one Solr and tell it, in that query you can say, when you run this, execute it against these 3 other servers, and then merge the results together. So if your index grows too large for one machine, you can run 4 or 5 Solr masters, each with 1/5 of your index on, and then you can do queries which pull results from all 5, merge them together and chuck them back at you. Thankfully, I haven't had to use that yet, and when I do, I imagine I won't just be able to do load balancing tricks, I'll have to actually get into the guts of Haystack and get that working. But it's certainly, it's not as difficult to shard your search as it is to shard something like a database. Because the databases, you've got joins going on and so forth. Whereas search, it's just documents, it's relatively easy to split them across different shards.
Do you know if it's possible to use as a backend Elasticsearch?
I really want to. So Elasticsearch is a relatively new search server. It's essentially what Solr would look like if they designed it today, using JSON as the sort of default thing. And it also does horizontal scaling. So out of the box, if you fire up 3 Elasticsearch nodes, they'll talk to each other, and then any document you index will end up sort of split between one of the others. So it's a really nice piece of software. There is a Haystack backend for Elasticsearch on Bitbucket. It's not very good. It's like most of it's little stubs. So I'm kind of hoping somebody else writes a backend for Elasticsearch before I have to do it. But yeah, it would be awesome if somebody would write that. I'll take one more question and then I'll move on to secret weapon number 2.
So you showed the example of how you put together the query by...
I mean, so I've got...
So using a format string there? So
am I using what, sorry?
Yeah, here you use a format string to put together a query?
Yes, this is quite a bad example. This is a kind of awful hack on top of Haystack. If you're just doing a search, you do SQS dot, I think it's auto_query, and then feed it in a string, and that will run it against the cluster. And there are filter methods as well, so you can say SQS.filter, just like you would with Django ORM. It even supports the same sort of __ GTE kind of comparison methods for data fields and so on. So it does have quite a comprehensive low-level API that's essentially a clone of the Django ORM, but against a search index. Okay. I will jump on to mini talk number 2. So the next thing I want to talk about is a project called Celery. Now, Celery calls itself a distributed task queue, and it's a shockingly powerful piece of software. It was developed originally by Opera Software. There's a team at Opera who are using it across, I believe, thousands of different servers. They wrote it originally as a sort of Django-specific thing, but I think a few months after they released it, they refactored all the Django stuff out. So now it's essentially a sort of general-purpose Python-based task queue manager. And so what Celery lets you do is control and farm out the processing of tasks to a whole bunch of different worker servers. So you have one queue broker, which you put jobs into, and then you have as many workers as you like that pull jobs off that queue, execute them, and then stick the results somewhere predictable where you can go and find them later. If you like, it's kind of like a Hadoop MapReduce thing, but it's designed for work that happens in real time. So you can actually have someone click a button on the web server, a job kicks off in the background somewhere, it runs to completion, while they're waiting with a little Ajax loader, and then they get the results straight up. I think today it's probably one of the most fully featured of any of the open source queuing systems. It's really amazing how much sort of power there is in the Celery package. But for my purposes, I'm building web applications. Really all I care about offline tasks. And by that I mean any task within that web app that's going to take more than about 200 milliseconds to run to completion. So there are a whole bunch of examples you can think of there. If you're updating a search index, the Haystack documentation actually points you towards Celery as a good way of managing that. If you need to resize images, anything where you're hitting external web APIs, where you might find where you can't guarantee that they're going to return in a decent amount of time, so you might want to farm that off to an offline task. Or the really big jobs, like generating PDF reports and things. And the beauty of Celery is that it takes all of the complexity involved in managing these workers and having this queue system and like measuring timeouts and all of that kind of stuff, and it hides it under the simplest imaginable API from the point of view of the end developer. So here's a really trivial example of a Haystack task. You do from a Celery task. If you do from Celery.task import task, it gives you a function decorator. You write a function which could do something that takes a while to complete. So in this case, I've got a fetch URL function which takes a URL and fetches it off the web and then returns the content. And then you stick the @task decorator at the top. So that function now will, if you call it directly, it'll work just as you'd expect it to work. But it also gains this .delay method on the function itself. And that .delay method, if you call it with an argument, that will, in the background, it'll actually wrap that, it'll serialize serialize the argument, serialize the message about which function you want to run, stick it on a message queue somewhere. The whole Celery infrastructure will kick in. It'll pass that task off to a worker that could be running on a machine pretty much anywhere. It'll run that code on the worker. Once the result comes back, it'll stick the result in some kind of shared storage, and then it's up to you in your calling code to do something with that result. The simplest thing you can do is just call on the result object that comes back. So this is an object which represents this task that's in flow. If you call the .wait method, it'll block until all of the sort of mechanisms in the background are finished, and the result is ready to return to you. Well, obviously, that's fine for if you're doing things in the interactive prompt. If you're doing something in a web application, the whole point is that you're not blocking and waiting for the task to finish. So I'll show you an example of how we're using this on Lanyard for something that's a bit more involved. We have this feature where talks given at conferences have a page. So this is a page called the Python and MongoDB tutorial that was presented yesterday. And then we ask people to add coverage to that session. So you can sign into the site, and if you know that there are slides in that session or a write-up on someone's blog or a video on YouTube, you can paste the URL in there, click the button, and we'll try and do something interesting with that URL. So in this case, if you click the add button there, and I was going to demo this slide, but the Wi-Fi unfortunately let me down there. You click the add button, we'll show you a little Ajax loading indicator for a few seconds, and then we'll take you to a page that looks like this one. So in this case, we've figured out from the URL that it's slides. We've figured out it's on a slideshow, so we've been able to put in an embedded version of that content, which will then get added to the site. We've figured out what the title of the slide deck is from using the slideshow API. There's a whole bunch of work that's gone on all the time while you're just sat there watching the little loading indicator running. And so here are just some of the stages we go through, and we're actually adding more complexity to this task all the time as we think of new interesting things we can do with URLs. The first thing we do is we hit a web API called Embedly, which is an API that essentially normalizes the YouTube and video and SlideShare and about 200 other services. They're embed APIs, the APIs that return a chunk of HTML you can use to display something on a page. And it makes all of those available through one endpoint. So we hit them up, give them the URL, and see if it matches any of the services that they understand. If it does, then we're done. We can move on to the next step. If it doesn't, then we make a request to that URL ourselves, and we pull back the HTTP headers, and I think the first 2 kilobytes of content there. So that means if somebody pastes in a URL to a 2 gigabyte movie file, we don't download the whole thing, but we do download enough to get an idea of what this thing is ourselves. If the content type is HTML, then we correct the title tag and use that as a suggestion. If it's not HTML, but if the content type is something like a PDF file, then we assume that it's going to be a slide deck, and we grab the file size as well, so we can store that and give people an indication of how big the files they're going to download are. And in the future, there are a whole bunch of other things we can start doing as well. Now, this clearly is not. This is a process that is not going to take. It's not going to be instant. There's a whole bunch of potentially long-winded steps involved in that. So it's an ideal candidate for running using a task processing key like Celery. So I'll just show you a little bit of the code that's going on. Behind the scenes, this is the code that runs when you submit a URL to us. We call our enhance_link function, which is the function that does all of that stuff. We call it with the delay method to pass it the URL. At that point, it's kicking off Celery in the background. It goes into our message queue. There's a worker firing up in one of our web servers somewhere. Everything gets started. But the object that's returned, which we're calling AR here, is this thing that represents the task that's running in the background. And every task has a task ID. So in this case, we construct a URL within our own application that encodes both the task ID and the page we should go to once everything's finished. It's just a URL so that we can do a straight-up redirect and send you, once the task is complete, we can send you to that place. Now, one of the things we do with Lanyard is we make sure that everything that works with JavaScript also works without JavaScript. At this point, more out of sort of bloody-mindedness on my part than anything else. But I like a web that doesn't require everyone to be running JavaScript. And so, with the offline processing, the way we do that is we have, if you're not using JavaScript and you submit a task, we redirect you to a full-page interface with a big ... waiting thing in the middle, and with a meta refresh tag set at the top, which after 3 seconds will hit the page again, and after 3 seconds will hit the page again. Every time it hits the page, we check to see if the task is done, and if the task's finished, we redirect you to that final URL. If the submission came in through Ajax, so if you've got JavaScript, when you click that add button, we notice that it's Ajax, and instead of redirecting you to that URL, we send you back a JSON object telling you where to check for updates. So then there's a little bit of JavaScript that runs in the browser, which pulls that URL every couple of seconds to see if it's done, and shows an Ajax loading indicator on the page while that's going on. So if you've got JavaScript, you get a nice little inline loading indicator. If you haven't got JavaScript, you get redirected to a full page, kind of like you get on like Expedia and travel booking sites and stuff, that tells you just to wait a few seconds while we prepare that result for you. Now at the end, all you have to do is, given the task ID and the message that the task has been completed, you can retrieve the result from Haystack's from Celery's default backend. So just like Haystack and the Django ORM before it, Celery lets you configure all sorts of different backends for both aspects of what it does, for both sort of queuing up the messages, queuing up the tasks that need to be executed, and for storing the results of those tasks somewhere that's shared. That means that you can pull it out at the end and do something useful with it. So I'll just show you the configuration that I pulled out of Lanyard for this stuff, just to illustrate how flexible this is. In our case, we're using, as the Celery queue, we're using Redis. The Redis server, it does sort of memcache style key value things, but it's also really good at queuing because it has there's a queue data type within Redis that you can pop things on one end and then have workers pop them off the other. So if you're not doing, I think the Celery documentation recommends using RabbitMQ, which is this enormous Erlang message queue with huge amounts of configuration, very, very powerful, but not necessarily what you want to have to figure out when you're in a hurry. So I found because we're using Redis for things around Lanyon already, it made sense to just use that as the message queue. But for the task results, for the things, in our case, the task result is a JSON object that tells us, yes, it was found on Bedley, it's got this preview HTML, it's got this title, or we didn't find it there, but we fetched its HTML, and we know the title's this, we know the length of the document. That needs to go somewhere so that it can be retrieved later on. We're actually using memcached for that. And the reason is that one of the things we worry about is people who, click that button, send it from those tasks, and they close the browser window and wander off. What we don't want to do is store the results of that offline process for the rest of history, for the rest of time, and they're never actually going to come back and process it. So by sticking in memcached, we take advantage of the fact that once memcached is full, the oldest things in it tend to drop out of it. So we don't have to do any housekeeping stuff ourselves, but those results will stick around normally for like a few hours, easily long enough for that user, for the task to finish and that user to finish adding the slides to the page or whatever it is they're doing. There are a bunch of other things that come with Celery. It really is a very comprehensive work management thing. One of the most interesting is a thing called Celery Beat, which is a separate process you can run for scheduling periodic tasks. So rather than having a cron tab somewhere, if you've already got this infrastructure set up to farm tasks out to multiple different servers, it makes sense to run your periodic scheduled tasks through that mechanism as well, so that those can be farmed out to different workers as well. And so Celery Beat lets you do that. There's a whole bunch of monitoring stuff which becomes increasingly important when you've got like a dozen machines all running jobs, and there's always a chance that one of those jobs is locked up because of a bug in the code or whatever it is. So it's very useful to have a good idea of what's happening in that cluster. So there are a bunch of tools that come out of the box for giving you like cursors-based interfaces for seeing everything that's happening and what tasks are running on different things. There's also a useful tool that lets you snapshot your cluster state, which again is useful for debugging. If you wake up one morning and it turns out that last night none of the jobs were running, you've now got a whole bunch of snapshots that you can use to try and figure out at what point things went wrong. So I'll give you one last example of one of the ways in which having this in your toolbox can make it much easier to build complex applications. And that's the activity stream pattern, which is something you see cropping up on more and more sites these days. It's essentially the Twitter challenge. If you're building a site like Twitter, how do you efficiently make it so I can go to a page and see everything that the people that I follow on the site have been doing in the past however long it is? The standard mechanism for doing this, and I think this is what Twitter and Facebook and I believe MySpace do now, is they have an inbox for every user on the site. So each user gets, kind of like email, each user gets an inbox. It's a list of IDs, and every time one of the people they follow does something, a pointer to that activity is dropped into that inbox, which is fantastic when you come to generate that page, because you can look at my inbox, say, okay, these are the messages, display them. There's no additional work done at that point. But it does have the challenge that if you've got somebody like Tim O'Reilly on Twitter, who has nearly 1.5 million followers, every time he does something, you need to write that message into the inboxes of 1.5 million people. If you're using something like Redis, again, for those inboxes, it can do 100,000 writes a second, so it's a pretty good candidate for that. But even then, Tim O'Reilly is going to take 1.5 seconds to fan out to all of those followers. But this is it's a classic example of something where having a message queue, especially one like Celery, which is already running, it's very easy to add new tasks into it, means that a big, hefty challenge like doing activity streams can be reduced down to just a couple of an offline task and a few lines of code. So I'll pause for a moment before I move on to Fabric and for any questions about messaging and Celery and how all of that stuff works. There's one right over there.
Hello. So you handle the situation where somebody has a lot of followers. Mm-hmm. How do you handle the situation where somebody is followed by a lot of people? Sorry, where somebody follows a lot of people?
So, do you mean with the stuff I was talking about earlier? Right, so we have this huge challenge with lanyards in that normally, if you build lanyards calendar view, the view that shows you the events that your friends are going to in the future, is basically an activity stream implementation. And so normally you'd expect us to use the mechanism that I just demonstrated with the Tim O'Reilly example. The problem is that lanyard uses the Twitter social graph. So when somebody signs into our site for Twitter, we look at who they're following and we generate the page then. And so a sizable number of our users hit us, and we've never heard of them before. We don't have their social graph stored locally. We have to pull it in from elsewhere. So unfortunately, for the particular case of us where our social graph lives elsewhere and we can't do a lookup that says, okay, tell me everyone who's following this person, we have to do a read, we have to build that activity stream at read time. Thankfully, with our particular domain where we're working with conferences, that tends to work out okay, because a conference has 500 to 1,000 attendees. There are only ever so many conferences happening in the future anyway. So we've found, especially now that we've replicated that across different things, that the performance is just about working. But it is possible if we end up with half the people in the world using the site at once, that we'll have to, well, probably move off the Twitter social graph at that point so we can do more of an inbox mechanism. Any other questions about offline processing? I was going to mention, if you've ever seen the site Doppler, which does, Doppler essentially keeps track of your travel plans, and it tells you when you're going to be in the same city as someone else, so you'll get an email from it saying, hey, you're in Florence, your friend so-and-so is in Florence as well. And Doppler is architected almost entirely on top of message queues. They've got, I think they're using ActiveMQ, and then most of the functionality on the site is a sort of 50 to 100 lines of Ruby that listens on the queue and then does something when somebody adds a new travel plan. So they calculate coincidences that way, they send out emails, they generate reports. And it's a really elegant way of working with that kind of sort of social data, which can get quite messy if you're trying to do it all in process. So the last tool I wanted to highlight, and I believe there's a session about this, I think there's a full session about this tomorrow, which talks about using it with Amazon EC2, so I'll only spend sort of 10 minutes on this one, is Fabric. Now Fabric really ties all of these ideas together. There's this thing where, a few years ago, if you were building a website, you'd essentially have like PHP and MySQL and maybe some Memcache if you were fancy, and that would be your entire stack, and that was fine. Today, if you're building anything remotely interesting, you're going to have all sorts of other components up and running. You'll have like a Solr search index somewhere, you'll have a Redis message queue, you've got Celery workers, Varnish cache servers. There's all of these different bits and pieces that come together to sort of build a modern website. And the problem for people like me, who have sort of come at this as developers, is this means that really if you need to be a sysadmin. If you want to build anything interesting at all, you either need to work with great sysadmins, or you need to pick up a lot of those skills yourself. I think any sysadmin will tell you that one of the most important first things you need to do is automate your deployments. Make sure that anything that you're doing that affects a production system is automated and repeatable. So there are a whole bunch of mechanisms for doing this, but Fabric, of all of them, Fabric is the one that I found which most closely matches to my sort of developer urge to get up and running really quickly and not have to think too hard about everything. The way Fabric is essentially just two abilities. It's a library that can turn Python functions into command line arguments, and it's this fantastic high-level abstraction over SSH. I mean, under the hood, it's running Paramiko, but it's a high-level abstraction for running commands on remote machines. So Fabric lets you write these very simple scripts with a bunch of shell commands, which you can then farm out to different servers operating different roles. And so automated deployments are absolutely essential for any project where you're going to be doing where you're going to be updating it, rolling out new versions and so forth. And actually I've got a whole bunch of projects that I wrote before I was using Fabric, which, like my blog's non-automated now, there's a bug I want to fix on it, and it means reverse engineering how I deployed the thing 2 years ago. So it's a real nightmare if you're not doing this, even for smaller projects. If you talk to a web operations person, they'll tell you to use Chef or Puppet, which are these fantastically powerful chainsaw tools that can reconfigure entire clusters in a moment. But my experience of those is they're actually quite hard to set up. If you look through the documentation, they really are, it really does expect you to completely change the way you think about systems administration. And as a rubbish sysadmin, I think about systems administration in terms of SSHing into a box and running commands. So the way Fabric does things actually fits my mental model really quite well. What Fabric lets you do essentially is take those commands that you were running and wrap them up in a few lines of Python and have them in a file in source control so that you don't have to think about them anymore. So I'll show you a couple of very simple examples. This is an actual Fabric command that we use for Lanyon. This is a clear cache command. Essentially, everything in Fabric lives in a file called fabfile.py. So you drop one fabfile.py into the root of your project and stick all of the automation stuff in there. So with this example, we're using Fabric's run command. And the run command executes a shell script, or executes a line of shell on a remote server somewhere over SSH. So I've got a clear cache function, and all it does is echo the text flush all, pipe through netcat into the local memcache daemon, so it clears out the memcache in the most sort of basic way I can think of. Then to run Fabric, rather than using the Python command, we use Fabric's fab command. So I can say fab-h, feed in a comma-separated list of servers that I want to execute this command on. And Fabric does rely on you setting up SSH keys and everything before you start using it, but you should be doing it anyway. And then, so you pass it in the servers you want to run it on, and then the name of the Python function you want to execute, in this case clear cache, and it does all of the work of setting up those SSH connections, running that command on the different servers you passed in, outputting the result to standard error. It does pretty much everything you need. And from my point of view, this is great because I figured out my shell command, and I add sort of 2 lines of Python around it, and I've got something which is in a file, which means it's in source control, which means that when I need to do it again in 6 months' time, I won't have forgotten how to do it. We actually use Fabric for pretty much everything, so we use it for our server installation and configuration as well. So here's a slightly more advanced example. This is installing Redis on one of our servers. And Redis is fantastic software, but it hasn't quite made it into most of the like apt repositories and things yet. So if you do want to install it, I was finding that I'd install it about once every 4 months, and each time I'd have to hunt down the URL that I got the thing from the last time and run through the same process. So I turned that into a Fabric command, which on the remote server, wgets a package that I happen to know works into the temp directory. It installs it using sudo and the dpkg command. And then the put command essentially copies a file from my laptop up to the server. So in this case, I'm shoveling my redis.conf into the source control into the temp directory. I move it into the place where where the package expects it to live. I restart the server, and I've got Redis up and running on a new server with just sort of one command. I type fab server name bootstrap _redis, and it all goes. And most importantly, I'm not going to forget how to do this again. So as the project evolves, your fab file slowly grows to document all of the patterns as you discover them. It's also fantastic for just learning systems administration because you tinker around on a server for a while until you figure out what works. You bake that into a fab file, and then you can start thinking about it in the future and like making it more effective or just rerunning it in different places. It's a great way of building up a cookbook of recipes that you know happen to work. This is another example. This time, this shows a couple of other Fabric concepts. Within Fabric, there's a global object called the environment object, env. And the environment object has a whole bunch of different hooks that you can hooks on it for configuring which servers Fabric's going to talk to, which SSH key is going to be used, that sort of thing. But you can also add your own properties to it to save bits of information that will be useful for other commands that run later on. And again, because most of these scripts are like less than 50 lines, software engineering essentially goes out of the window. Global variables are fine. It's all good. Just get something that works. So in this case, what I'm doing is I have a fab git _export command, which exports the archive out, exports my Git repository, dumps it in a place in the hard drive from which I can then push it up onto the server. And I do that using, I actually create a directory based on the current date and time. That's so that when I copy it up onto the server, I have, for every deployment I do, there's a chunk of code in a date-stamped directory, which means I can do rollback and roll forward, which I'll show you in a moment. Essentially, I'm recording the path that I'm sticking things in the env object. The local command runs commands locally on your laptop as opposed to in the server. And it's one of those things where, like, git archive -- prefix = landed -- format = tar. It's it's one of those commands I just kept on forgetting. So having it there in the fab file, where I'm never going to have to figure it out again, is a really useful external memory. So I'll show you how the rollback stuff works quickly. The way we're doing rollbacks is very straightforward. We're just doing it with symlinks. So when we deploy code, we stick it in one of these datastack directories, and then we have this bit of code that runs, which removes the previous symlink, renames the current symlink to the previous symlink, and then links the current symlink to the directory, the database directory that I've just deployed. This is also illustrates one other feature of Fabric. If you say with settings 1 only equals true, that means that within that block, any commands which fail will be ignored. It will put out an error message, but it won't cancel the entire process. So that's useful, so that the first time you run this, if the previous directory hasn't been created yet because you've never deployed before, you don't get the whole thing being die on you. And then for the rollback, it's a very similar kind of process. It's just a case of renaming the current directory to _previous, renaming previous to current, renaming _previous to previous, and you're back at the version of code that you were running beforehand. I'll show you one last Fabric hack. This is a little bit horrifying, but again, this is because I haven't been able to figure out Chef and Puppet yet. I'm a little bit terrified of them. So I ended up essentially reinventing them. I realized that one of the problems I had is that I've got multiple servers, like the database is over here, and I've got server slates here and here, and memcached across these 3 different places. And so every time I made a change to where it was, I had to go into my Django settings and reconfigure which memcache servers it was talking to, and I had to make sure that I had the things installed on the right servers, and all of that kind of thing. It was an absolute nightmare. So what I have now is a JSON file, again, in the source repository, which defines all of the servers I'm running. They're all on Amazon EC2, so for each one it defines its instance ID, the public DNS, the private DNS, and the private IP, and gives them a name. So I have app server 1, app server 2, load balancer, that kind of thing. And then in the same file, I've got a bunch of roles. So I say app server role is app server 1, app server 2, the Redis one is services 3, memcached is app server 1, app server 2, services 3. All of that kind of thing. Now, because servers.json lives in the repository, it gets deployed with everything else, and then my Django settings.py actually starts out by reading this file in and using it to configure the memcache settings, it configures the database from it, it configures which Solr servers it talks to. All of that stuff comes from this one file. It also means that the Fabric file can read this and can use it to figure out which servers to talk to when installing things. So if I want to clear cache, I can say fab roll memcache to clear _cache, and Fabric will look at the JSON file, figure out which servers to clear, and run through them like that. And the reason, and Fabric makes it really easy to do this kind of thing because it has this env object. There's a magic property in env called hosts. Env.host is the list of servers that the commands will all be run on. And so I've got 2 functions that I've written. There's a function called server, where if you give it a name of the server, it appends it adds that server's details and its public DNS to the list of hosts that run commands. And then I've got a role function, which given the name of the role, like memcache, will look at all of these servers, all of the server names in the memcache role, and for each one it'll add it to the list of servers to execute, and then it'll run the command. So again, this is, I like tools like Fabric, which are very easy to hack around with. This ended up being about 7 lines of Python, but it gave me the ability to categorize all of my servers into different roles, read the configuration into Django from the same place that was configuring my servers, all of that kind of thing. I've even taken that step further, and I have a dynamic nginx configuration where, and this again is a Fabric file, and I'll put these slides up later, where when I deploy the nginx config file, it looks in that JSON file, figures out what the different backend servers are that need to be load balanced to, and bites that out into the configuration, uploads the configuration through Fabric, restarts nginx. So all of that stuff is automated again off that one bit of JSON. So I think I need to stop in a moment so that you can get to the next session. But I can probably take a couple of questions on how all of that works.
How would you compare Fabric and Paver?
Paver I haven't used at all, so I couldn't. I've compared Fabric to Capistrano in the past, which is a Ruby library that does most of the same kind of stuff, but no, I haven't used Paver, so I don't know how it compares. This question there?
Actually, we don't have more time for questions, so if you want to...
Okay. If you go there in about, as soon as I've got Wi-Fi, all of the slides will be available, so hopefully sometime this evening.
Okay.
And thank you very much.
Thank you.